Good morning to all. Myself, Dr. Arun Egemia from Aerospace Engineering Department. Today, I am going to take one topic from fluid mechanics for aerospace for second year aerospace students. So, that topic name is velocity triangle for pumps. So, before introduction this topic, so what is meant by velocity diagram? So, in that velocity diagram triangle for a pump uses two vector additions to represent the absolute velocity that is called as W and relative velocity that is called as capital V and blade velocity capital U and inlet and outlet of the impeller. So in that triangle, it will be drawn by following these cases like capital V, capital W and capital U. So here these are all the main cases. So in that two types of angles it can be utilized for these cases. First one is alpha. It is called absolute flow. Second one is beta. It is a relative flow. So here we will utilize it for the visualized fluid path through the pump impeller blades can be used for these cases. So the velocity diagram it can be classified into two types. First one is the inlet and outlet diagram. So in that inlet triangle, so in that cases it can be suitable for this centrifugal pumps only. So here the fluid enter radially, meaning the absolute velocity is perpendicular to the blade velocity. That is called as a inlet triangle. Next one is a outlet triangle. So here the absolute velocity, relative velocity and blade velocity form a triangle at the outlet. That is called as a outlet triangle. So in that relationship between the inlet and outlet triangle is capital V equal to W plus U. That is called as a relationship between the both cases. And next one is a velocity relationship. Already I told you. So in that velocity relationship, absolute velocity capital C equal to W plus U. So the angle alpha is nothing but a angle between the absolute velocity and blade tangential directions. So the blade it can be fitted some angle that is called as tangential direction, and beta it is a angle between the relative velocity and blade directions. So by the performance calculation, we will calculate by using the by using some formulas. So the tan alpha equal to Vf by U1 or tan beta equal to Vf total by Vw1 minus U2. These are all the formulas which can be used for this for calculating the velocity, power, or torque. These are all the cases. So in that real case, industrial centrifugal pump. So here the for application vises the for in BPCL refinery pump. So the velocity triangles it can be used to optimize the pump. So in that things, the what are the parameter we will optimize using the velocity triangle. So first one is the impeller feed and flow rate. It can be optimized. Next one is a blade angle and blade angle for maximum efficiency. For example, some cases the if the efficiency is more means the blade angle it will be some cases the blade angle it will be change the directions. And next one is the adjusting the relative angle. It can be reduce the flow separations. So by implementing the velocity triangle to the refinery pump, definitely we will improve the pressure, rate and overall pump performance in these cases. For aerospace sector, so we will using the jet engine fuel pump. So in that jet engine fuel pump, it can be utilized for these cases. So in that cases, the more amount of speed we will found in that cases. So around 450 meter per second velocity found in that cases. So by using this velocity triangle, we will compress the fluid effects and minimum shock losses. So during the flow of water, the more amount of shock formed in that inside the pump. So due to this formation of shock, the damage it will be occur. By using the velocity triangle, it can be reduce the formation of shock during these cases. So these are all the important parameter for drawing these cases. The first one is inlet U and inlet W and inlet C, inlet. So by relating this equation, so finally we will get C equal to W plus U. So, so thank you. So we will catch you on next topic on next video.